Okay, good to see the hall packed. Nice to see you all here. My name's Ralph Ellis. The talk today is climate, energy and misinformation, because I think this has been very badly taught. Now, can you see my red spot if I do that? Yes. Good, because that probably makes it easier. As Christabel was saying there, I've been flying for 40 years. I know the climate, I know weather. And so my talk today is about climate and energy misinformation, because this is a very important subject. It's affecting us all now with our taxes, with our energy bills, with our net zero. And I think it's so badly taught that this is not misinformation, this is disinformation, because it's being deliberately badly taught. So what do I know about climate? Well, this was my last climate paper, so I write climate papers as well. Modulation of Ice Ages by Dustin Albedo. We're not going to talk about this. I'll do a little bit about this in the next talk in an hour's time. Very successful, 45,000 downloads. And, sorry, I've got to keep this side of the marks, otherwise I'm not on the camera. Fairly controversial because it says that CO2 is only a bit player in temperature control on the planet. So, how did this all start? Oh, yes, we're going to do one graph from this climate paper. So this comes from my climate paper. Temperature versus CO2 during the ice ages. So this is 800,000 years of data. Temperature versus CO2, and as you can see, they are in lockstep together. And some climate scientists have erroneously assumed from that that CO2 is controlling temperature. But, as you probably know, correlation does not imply causation. You need a reason for this causation. And we can look at this graph in a slightly different fashion, and we could say, every time CO2 is high, the world cools. And every time CO2 is low, the world warms. So we could say from this data, high CO2 causes cooling, and low CO2 causes warming. Now, it's more complex than that, but I think from this you can see that there are other factors involved in temperature control on the planet, because this would not happen if CO2 was a very strong greenhouse gas. So, how did this climate alarmism start? Our climate misinformation, which I think is actually climate disinformation, it's deliberate. How did this all start? Well, it started with hiding the decline. I don't know if you remember this from the ClimateGate emails. Wonderful things they are. This is a temperature graph from tree rings for 1,000 years, known as the hockey stick graph. And the temperature runs along, not doing very much until we get to sort of 1950. And then the temperature zooms up, and we're all going to fry, apparently. This was taken from tree rings. I really don't like tree rings as a proxy for temperature. Trees are more affected by moisture than they are by temperature. And we can see from just this one tree ring, when they take the temperature, when they take a core, they actually take a core through the tree, which is only about 1 centimeter thick. So they don't chop down the tree, they're taking one core. Now, if you take the core from the 10 o'clock position, we've got nice thick tree rings. But if we move around to the 2 o'clock position, we get nice thin tree rings. So was it hot or was it cold? Same down the bottom. We have thick tree rings and we have thin tree rings. So I don't think trees are a very good proxy for temperature. So here's that graph again. How was this graph created? Well, we can see that from the ClimateGate emails. So this is an email from Phil Jones to Ray Bradley and Michael Mann and Keith Briffa. These are all climate scientists. And it says, let's have a look. I have just completed Mike's nature trick. So Mike is Professor Michael Mann, and Nature is the science magazine Nature. So it says, I've just completed Mike's nature trick of adding in the real temperatures to each series for the last 20 years. from 1981 onwards and from 1961 for Keith Briffa's data in order to hide the decline. So what was the trick and what was the decline that they were hiding? Well, we can see that from Keith Briffa's data. This is his tree ring data. Again, this is a tree ring data as a proxy for temperature, and tree rings are not a very good proxy for temperature. And the temperature runs along, this is 600 years of data, all the way from 1400, runs along all the way to 1950, and then the temperature declines. The temperature goes down in the late 20th century. And this is not what they wanted. So this is the decline they were hiding. Now this has a name. This is called the divergence problem. The divergence problem says that tree rings record temperature perfectly for hundreds of years until 1950, and then they stop. And if you believe that, I've got a bridge to sell you. So what do you do if your data has a divergence problem, if the temperatures decrease after 1950? Well, it's easy. What you do is you chop off the end of the graph, you add in the, come on, you add in the temperature data from thermometers, and you get yourself a hockey stick. And that is how the hockey stick graph was created. This is going back way back into 2002 or 2004 or something like that. That's why the hockey stick graph has a different color on the end of it, because it is a splice of two different data sets. And the problem is, if trees cannot record temperature after 1950, why should we believe that they're recording temperature for 1,000 years before that? So that is how the climate alarmism started. And it continues to this very day. You're probably all familiar with this. This is from the BBC. I love taking the mickey out of the BBC. UK weather maps. Question, which is the warmer weather? Well, it's the one on the left, of course. So what's the difference? Well, the BBC decided to join in the alarmism. They said this colouring was to aid people with visual impairment. Yeah. Does anyone think that that's easier to see than the one on the left? No, that was part of following the agenda, basically, wasn't it? And we get this all the time. Now, I'm just going to run through some climate data, weather data, that you're probably not familiar with, because it's not on the television, it's not in your newspapers, it's being hidden from you. So, USA tornadoes. What's happening to those? You probably all know they're getting worse, they're getting stronger, they're wiping out towns all over America. Well, let's have a look at the data. This comes from the NOAA Storm Prediction Center, NOAA, National Oceanographic and Atmospheric Association or something. Anyway, this is USA tornado numbers. This is strong tornadoes, F3 to F5. We've got 70 years of data. Now that's climate. Anything over 30 years is climate. And as you can see, strong tornadoes have been decreasing for 70 years. And if you didn't know that, why didn't you know that? Why is that not headline news? Same with tropical cyclones, hurricanes, typhoons. You probably all know what's happening. They're getting worse, they're getting stronger, they're wiping out coastal communities all over the place. Well, let's have a look at the data. This comes from Dr. Ryan Mao, who runs all of the satellite data on tropical cyclones. And he has here 40 years of data. That's because it's satellite data, basically. And if you look at the top of this graph here, the top line is all hurricanes, and they have been decreasing very slightly over 40 years. And the bottom one is strong hurricanes, and they have been steady, no change in 40 years. We can take this back further, back to 1850 actually, by using proxy data. So this is from a paper just last year, 2022. It's by Chand et al. There you go. It's running very slowly at present, but there we go. This is by Chand et al. 2022, as I say. It's a peer review climate paper. And as you can see, tropical cyclone numbers increased from 1850 up to 1900, and they have been decreasing ever since. Decreasing. So where is the climate alarmism in that data? Where is the climate emergency in that data? It doesn't exist. This is what I say. This is the alternative information that the BBC will not give you. What else do we have? So there we go. It's going up to 1850, and then it comes down after that. The next one is snow extent. You probably remember the quote from Dr. David Viner of the CRU over in East Anglia, and he said our children will not know what snow is because of global warming. Well, let's look at the data. This comes from the Rutgers Snow Lab, which is Rutgers University over in America. And they run the Snow Lab over there, and here we see data for 50 years. Again, that's climate, it's 50 years. And winter Northern Hemisphere snow extent has been steady, no real change over 50 years. Polar temperatures and ice sheets. Now this is a real mixed bag. You're all aware of the problems here. The Arctic sea ice is melting. You know, we're all going to drown, even though it's sea ice, but never mind that. So let's look at temperatures first. Come on, there we go. So on the top here we have Arctic temperature. On the bottom we have Antarctic. Now on the top, Arctic temperature has been increasing very slightly. It's increased by 1 degree over the last 40 years on this one. Again, because this is satellite data, it has to be 40 years. But Antarctic temperature, steady, no change in Antarctic temperature. So don't believe this nonsense that Antarctica is warming. What they normally say is the Antarctic Peninsula, which only represents 2% of the whole of Antarctica. So no change in temperature. So we have a discrepancy, a difference between north and south. Same with the sea ice. Let's look at sea ice. It'll get there eventually. So this data is from the NSIDC, that's the National Snow and Ice Data Center over in America. This is all recognized data organizations. And what do we have here? In the blue, we have Arctic sea ice, and that has been going down for 40 years and is now slightly increasing. That's why you're not hearing about it quite so much over the last couple of years. And Antarctic sea ice has been increasing for 35 years, and then it's decreased because of 2 very large storms that they had down in Antarctica. So, yeah, none of that correlates whatsoever with CO2. One is increasing, the other is decreasing. What's the difference between the north and the south? Why should there be a difference? If it's CO2, CO2 is a global gas. You would expect global responses. But here we have a difference between Antarctica and the Arctic. Well, we don't know what the difference is, but one possibility might be something like this. This is what the Arctic looks like. This comes from the Dark Snow project, which was 10 years ago, but they lost their funding because they were not looking at CO2. Yeah, there's a lot of industrial dust on the ice sheets in the north. That will have a difference on warming, albedo, melting. Not exactly pristine, is it? And we'll talk about this in my next talk in about an hour's time or so, because this is a part of the climate paper that I wrote. So anyway, leave that with you. We go on to polar bears. This is the real canary in the coal mine for the climate industry, which is why something like this from the BBC, this is pure disinformation. What do they say? Polar bears will be wiped out. Why the alarmist language here, wiped out? They're not going to be wiped out. by the end of the century, unless more is done to tackle climate change, a study predicts. This was in 2020, a year after the data came out. Now, the BBC must have known about Susan Crockford's data, so this is pure disinformation. So let's look at the data that she got. She is the scientist who investigates polar bears. Here's the data. We've got, what have we got? 60 years of data here. And polar bear numbers have been increasing for 60 years. This is by Dr. Susan Crockford. If you want to read it, it's available online. It's the State of the Polar Bear Report 2019. That's the latest data we've got. So polar bear numbers have been increasing. Not only increasing, they have quadrupled over the last 60 years. Again, where is the climate alarmism? Where is the climate emergency in this data? This is the data that the BBC will not present. And world food production, I've added this one in. I didn't have this in last time because I've just noticed some bleeding heart climate evangelists on the television saying food production is being affected and because of droughts and floods and God knows what, lightning strikes, I don't know. Anyway, what's happening to world food production? Well, it's increasing, of course. This is the latest data. This comes from the United Nations Food and Agriculture Organization. Latest data up to 2021, and all food production around the world has been increasing, except for sugar, but that's more to do with taste changing than anything else. We're not using quite as much sugar as before. But all the major ones, the cereals, the vegetables, the oil crops, the roots, the tubers, they're all increasing. We're not running out of food because of climate change, and we'll look at this in a minute as well. We're probably actually gaining food because of climate change, or extra CO2, should I say. So that's the alarmism we get, but if you mention anything else in polite society, they will immediately say, well, 97% of climate scientists agree with anthropogenic global warming. No, they don't. Where did this come from? This came from John Cook et al., 2013. There have been follow-up papers, but they all make the same deliberate mistakes. So what did they do for this paper? Well, they got 12,000 climate papers, and they had a look through them, and 66% expressed no opinion on climate, so they threw those out of the window. Of the remainder, 3% of papers with an opinion rejected global warming. Ergo, you might say, 97% of papers with an opinion supported anthropogenic global warming. That's where the 97% comes from. But it's fraudulent. That's not what the paper said. If you look through the rest of the data, only 24% supported global warming. But that's a very broad question there, because I would have to be a 24%er, even as a climate realist, because there has been some warming. We don't quite know what's causing it exactly, and we don't know its magnitude, but there has been some warming. So I would have to be a 24%er. But the paper goes on. Only 8% implicitly endorsed anthropogenic global warming. Only 0.5% explicitly supported the IPCC version of global warming. So it was not 97%, it was 0.5% who actually agree with the IPCC. And the trouble being that all climate scientists are paid to agree with anthropogenic global warming. He who pays the piper calls the tune. I had that problem even on my own climate paper, which was rejected by the Royal Society because it did not support CO2 global warming. And if you don't agree, you end up like these climate scientists who got thrown out of their jobs because they didn't agree. So that's the problem with modern science. There is no freedom of research, there's no freedom of speech, there's no freedom of publication within the scientific community. And that actually goes for a lot of things. You've probably seen all of the problems with COVID-19. It's the same problem. It's the same problem. So we come to net zero. Because of all of this alarmism, we have this net zero being dumped upon us. If there was no problem with CO2, we wouldn't have this net zero. So what do I think about net zero by 2050? Well, you might be surprised, as a climate realist, I support responsible net zero. Responsible. But not because CO2 is a problem. It's because we will run out of fossil fuels at some point. Whether it's 50 years, 100 years, 200 years, at some point in the future, we're going to start running out of fossil fuels. So we need to make a transition. Because, I don't know if you know this, but Britain hit peak coal in 1913. Peak production of coal. That's a century ago. We hit peak oil in 1999 and peak gas in 2002. We in Britain are running out of fossil fuels. So at the very least, in this part of the world, we need to make some sort of transition. We can't be dependent on Oman and so on for gas, and North Africa. That's just ridiculous. But if we can run out of fossil fuels, so can the rest of the world, basically, at some point, whether it's a century or 2 centuries or whatever. Regards CO2, however, we need more CO2, not less. Why? Why do I say that? Well, the unspoken truth, because again, you'll never see this in the mainstream media on the BBC. The unspoken truth, CO2 is plant food. Very, very basic, but they won't tell people especially on Children's Hour on the BBC. So what's the difference between these plants? Well, CO2, of course. Those on the left have got lots of it. Those on the right have got very little. We were just speaking to a lady out in the kitchen who's involved in greenhouse growing. So what's the CO2? So yes, CO2 is the most essential gas in the atmosphere. Without CO2, all life on Earth will die. So we need CO2. Where are we at present? We're at 400 parts per million, and the plants are doing reasonably well, as you can see. But if they had more CO2, they would do even better. That's why greenhouse growers pump extra CO2 into their greenhouses, to make the plants grow more quickly. Conversely, back in the last ice age, CO2 was 190 parts per million. Now, this is only 18,000 years ago. It's not very long. Not very long indeed. And up on the highlands of Asia, north of China, the CO2 concentration, the equivalent CO2 concentration came down to 150 parts per million, at which point all of the plants are dead. And that's a problem because low CO2 equals plant death and therefore equals CO2 deserts. Now, you're all familiar with a precipitation desert, no rain, no plants, you get a desert. Same happens with CO2, not enough CO2, all the plants die, you get a desert. Conversely, back in the Jurassic era, the good old dinosaur era, CO2 was 2,500 parts per million. That's 6 times higher than now. And the biosphere was fine. You could say that the large size of dinosaurs was due in part to extra CO2. More CO2 equals bigger plants, equals bigger herbivores, equals bigger carnivores, and you end up with the dinosaur era. So don't let any uneducated teenagers try and tell you that CO2 is bad for the biosphere. Quite plainly, it's good. Energy policy, again, this brings us back to the energy policy because this is affecting us with our taxes and our energy bills and everything else. So what is the government policy? Well, I don't think they have a policy. I think they have an energy fantasy because they don't know what they're doing. They've got absolutely no idea, these people. So let's look at UK electrical generation. Oh, this might be a bit boring, but anyway, it's sort of vaguely important, you know. What sort of energy are we using in the UK? This is electrical production in the UK. Over on the left is the renewables, so that's wind and solar, and the blue is the bio and waste. So we're now up to 39% renewables, and you might say, hooray, we've gone sort of renewable. Well, maybe not quite, because that blue bit on the left there, that is Drax the Destroyer. Drax used to be our biggest coal-fired power station, which used to sit on top of its coal field. But now they're chopping down trees in America, they're pulping them, they're putting them on ships, they're transporting them across the Atlantic to the East Coast, putting them onto trains and then trucking them down to Drax. And Drax is burning down all of the trees in America. Is that a good idea? I don't know, I'll leave that with you. But one thing we do know is Drax is now putting out much more CO2 than ever did when it was burning coal. The other problem is UK fossil fuels are only 1/40th of what they're burning in China. Let's have a look at the Chinese pie chart. Here it goes. And as you can see, it's mostly black. Why is it black? Well, that's all coal, basically. So we've got 64%, 615 gigawatts of coal, being burnt in China, just for the electricity. That's not all energy, that's just electricity. So we have, if you look in the left-hand corner here, we've got 16 gigawatts of fossil fuels being burned, and China has 615. So if we want to put our pie chart on there in comparison, here we are. This is Britain. Yeah, totally insignificant. So whatever we do has no effect. We can destroy our economy, we can destroy our industry, and it will have absolutely no effect on CO2 output if you think CO2 is a problem. The other problem is, what is China doing to its fossil fuel consumption? Is it reducing like we are by 2035, by 2050? Well, no. Last year, China built or commissioned 50 gigawatts of coal-fired power. That's like 2/3 times more fossil fuels than Britain is using. And they commissioned that just last year. So they're increasing their fossil fuel consumption. There is another problem. Electrical production is not energy. So here we've got the same old chart that we had before, UK electric generation, and I want you to have a look at the size of the red sliver, that's oil, and the yellow, that's gas. Now if we go from electricity to all energy, now they increase a bit. Okay, so why the difference, why the change? Well, all energy includes transport, space heating, and industry. And obviously a lot of those are oil and gas. So renewables now come down to only 16% renewables if we take into account all energy. So power generation needs to increase by 300 or 400% from what we've got at present if we want to go all electric by 2050. That's the government's idea. The government wants to be all electric by 2050. So we've got to increase electrical production by 3 or 4 times. And where are those power stations being built? As you know, power stations are like 20-year lead time on some of these power stations. We've got to start building them now. Where are they being planned and built? And who's going to pay for them? This is why I say they've got an energy fantasy, not an energy policy. The other problem is backup. They're going to get rid of gas by 2035. So we're going to need some form of stored backup. So what stored backup do we have? Well, how much do we need? So we can calculate exactly how much we need just here. It's very simple. So UK electrical generation is 40 gigawatts in the winter, roughly. Sometimes it's a bit more than that. Here is a graph of electrical generation in the UK. This is for December 2021. So purple is gas, wind is blue, and yellow is solar. Note there is no solar in the winter. Don't let people try and persuade you that solar works in the winter. It simply doesn't. Look, there is none. There's just a little tiny thin line. The other problem is that you get wind outages. This is the problem with renewables. So here we had a 6-day wind outage with no solar. Now, how did they bridge that gap? Well, they brought in the gas, of course. So we're using gas as a backup. But if the gas is all switched off by 2035, how are we going to bridge that gap? How are we going to stop the lights from going off? Well, obviously, we need some sort of stored backup, and it's probably going to be pumped storage. So how much do we need? I think we need 10 days of stored backup. Now, the government came out with a report recently saying we need 30 days of stored backup. So multiply what I'm going to say here by 3. You know, I'm being very conservative here. 30 days of stored backup. Anyway, we're going on 10. So what we need is this much. 4,800 gigawatt hours of stored energy. Don't worry about the units, just have a look at the magnitude of it. 4,800. But that's not the total problem, because electricity is not all energy. So for all energy, you have to multiply at least by 3 or 4. So yeah, electricity represents only 25% of our total energy consumption because of transport and space heating and industry. So we actually need 19,000 gigawatt hours of stored energy. 19,000. More if you go on the government's recent report. And the problem is we only have 10. So we need 19,000 gigawatts of stored energy. We only have 10 gigawatts. That's de Norwig. We'll have a look at de Norwig in a minute. You can see there's an almighty gap here between what's required and what's being planned. So let's have a look at de Norwig. It's a pump water storage facility. These are the best, actually. They are the most efficient. Basically, you pump water up and then you let it flow down again when you want to generate some electricity. Well worth visiting if you happen to be up in Snowdonia. It's called Electric Mountain if you're interested in technology. Fantastic site to see. Hugely expensive because the Greens didn't want it in Snowdonia, so they made them put this generating set inside a mountain. So they hollowed out a mountain with a cavern bigger than St. Paul's Cathedral, and they put the power station in there. That's why it was so expensive. Trouble being, we're going to need 600 de Norwigs. Where on earth are we going to put 600 de Norwigs? And how long is that going to take? And what's that going to cost? Well, we can cost that out, actually. De Norwig cost 1.7 billion in today's money, because this was built back in the 90s sometime, or maybe even the 80s. So total cost of storage facilities, 1,000 billion. Now, the government came out with a recent paper recently saying total storage requirements 200 billion. Like 5 times as much is what we require. And we can confirm this with the latest one we're building, which is Corrie Glass. I don't know if you've heard of this one. This is up in Scotland. This is the upper pond where they pump the water up into it. That's going to cost us 950 billion based on the costings, recent costings, because that's still under construction. They're still building it now. So that's a fairly good estimate. 1,000 billion is what it's going to cost us for the backup, stored backup. So the government is not serious about Britain converting to electric generation using renewable energy unless they can address the energy storage problem. If they don't have energy storage, the lights are going to go out all over the nation. Now, this was known about, the government's known about this for ages. This was a report by Professor Mackay. He was the former government science advisor. He wrote this book. It's well worth reading, actually. It's slightly out of date. It's like 15 years old now. Without hot air. And you can download it free PDF. The trouble was that Professor Mackay, who was an uber greenie, could not get renewable energy work to work for the UK. So he came out with 5 plans, how he might sort of try and get it to work. And as you can see, each plan has a major block and then lots of little tiny things down the bottom. And so the major blocks that he came out with were, well, quite obviously, oh, that's not supposed to come up all at once, but there we go. Offshore wind is the first one. So this is only for 60% of our energy needs, not all of it, only for 60%. We need 100 Hornsea 3s. So Hornsea 3 is the biggest wind farm in the world, out in the North Sea at present. They're still constructing it. We need 100 of those, costing 850 billion. Yeah, lots and lots of money. But that's not the only problem, because they wear out after 25 years, so you've got to renew them. That's another 850 billion. Wind doesn't blow all the time, so you need the stored backup. That's 1,000 billion. So your total cost there is 2,700 billion. And that's only for 60% of our energy needs. If you want to get 100%, that's going to cost you 400 billion. 4,000 billion. That's 10 times more than the government projected in the Royal Society report, which was released just 2 weeks ago. 10 times more is what's required. That's the trouble with their costings. Their costings are going to lead politicians down the garden path thinking this is doable, because they've costed it at 400 billion, when it's not. It's going to cost them 4,000 billion. And then where are we? This is why this needs to be debated rather more than it is, especially by the media. These are supposed to come up one at a time. Never mind. Anyway, it's coming up as a block. The second main block is solar in the Sahara. Now, Professor McKay, in the government report, this is like from 15 years ago, he recognised that solar doesn't work in the UK. Because we need the energy in the winter and we have no sun in the winter. So he said, okay, so it doesn't work in the UK, we'll put the solar panels in the Sahara. Sounds like a reasonable idea, you know, lots of sun down there. Unfortunately, this is a bit of a fantasy. We're going to talk about green fantasies later. So anyway, he wanted to put the solar panels down in the Sahara. We would need 3,900 Wroughton airfields. I don't know if you know Wroughton Airfield. It's just south of Swindon. It's our largest solar farm at present. We need 3,900 of those. Fairly cheap, though. 320 billion, yeah. If you consider that cheap, of course. But you've got to renew them after 25 years, so that's another 320 billion. Then we need rent. I've costed the rent at 30 billion a year, because it's not our land. You've got to rent it from the North Africans. And you've got to rent the land for the cables to come back through France and Spain. So rent is 1,500 billion over a 50-year project. And then the cabling. Now the cabling's really getting difficult now. The costings I've got here are based on Swedlink, which is the new cable they're building from northern Germany to southern Germany. And they're having terrible problems with that. The Greens made them put it underground, so it's not an overground cable, it's an underground cable. And it's proving hugely expensive. But we would need the equivalent of 340 Swedlinks in order to get that energy back from North Africa and pipe it back to the UK. And that's 3,100 billion just for the cables. Totally impractical. So if you hear people are talking about the interconnected world in terms of energy, it's not going to happen. It's not going to happen. These are using the new HDVC, I think they call them, HVDC, the high voltage DC cabling, which is, you know, the most modern we have. And then we need some stored backup. The sun doesn't always shine, even in Sahara. They have nighttime there as well. So we need the stored backup. That's 1,000 billion. So we're talking about 6,240 billion if we want to put some solar panels in the Sahara, which is not going to happen. Last one, nuclear power. Had a bad rap over the last 40 years, but nevertheless, if you're worried about CO2, it's a good contender. So nuclear power, well, we've got good costings of that because they're building Hinkley Point over in Somerset, of course, so we've got the costings from that. We would need 30 Hinkley Points, cost of 600 billion. Are we going to build 600? Are we going to build 30 nuclear power stations by 2050? It's taken them like 25 years to build Hinkley Point, and they're only halfway through it, sort of thing, you know. Yeah, it's not going to happen. So this business of getting this all complete by 2035 and then by 2050, it's simply not going to happen. It's a energy fantasy, not an energy policy. Fuel, unfortunately, nuclear power requires fuel. So that's another 500 billion over 50 years. So it's not too expensive, I suppose. Maintenance, I've put that in there because, well, all of these things need maintenance, but nuclear power stations tend to want more maintenance than other facilities. So I bunged that in there at 500 billion. So we're talking about 1,620 billion for nuclear power. And that's only for 60%. That's not all of our energy needs. We're still going to need the other bits, you know, the bits of tidal, bits of bio, bits of whatever, wind power. So hugely expensive. This is why I don't think any of this is going to happen. And the other problem is, where is the economic bonus for Britain in this? We're being promised this green energy revolution which will invigorate our economy. Well, let's take Hornsea 3. Hornsea 3 is being built by a Danish company using Swedish turbines, using German generators and gearboxes, and using Japanese cabling. Where's the bonus for Britain in that? Yeah? They're just not thinking about us at all. Solar in the Sahara, you can bet that all the solar panels are going to be made in China, and the cables will be made in Germany and Japan, which are the big cable makers at present. Nuclear power. Well, nearly invented. We were at the forefront of nuclear power with our power stations. So where do we get the nuclear power from? Well, China and France, of course. We've abandoned our gas-cooled reactors, which did very well, by the way, you know, working for 50 years. And we're going for Chinese and French pressurized water reactors. Yeah, okay. So no bonus for Britain in any of that. Let's have a look at CO2 and safety, because that's paramount, of course, if we're looking at nuclear. So this is CO2 emissions, as you can imagine. Coal at the top, natural gas. Way down the bottom here, we've got wind, nuclear at the bottom. Same with safety. Of course, if we're talking about nuclear power, this comes from Our World in Data. Which is the most unsafe? Well, brown coal. I don't know if you know, but in China they were losing hundreds of miners every year mining coal. Brown coal, coal, oil, biomass. Down the bottom we've got wind, nuclear and solar. Okay, nuclear gets a bad rap, but 3 Mile Island, nobody died. Fukushima, only one person died. So in essence, it is quite safe. Could be made safer, of course. Nuclear problems, let's quickly run through these if we're looking at nuclear power, because some of this you might not know, so it is interesting. Uranium power, let's look at that first of all. It's low efficiency, only 0.5% of the fuel you put in is burnt. That's because the fast breeders did not work. The only people with fast breeders are Russia, China and India. We don't have any anymore. So we've only got 200 years of uranium left if the world goes to uranium power. It's like having fossil fuels. There is not that much of it around. And by available, I mean until it gets scarce, and then it gets much more expensive, of course. You need reprocessing plants, you need storage of half-life waste products, 20,000 years, 30,000 years, you know all about it. Somehow you've got to store all of that, and you've got the possibility of meltdowns. We've had 3 already. What's the alternative? The alternative is thorium. Here he is, Mr. Thor himself. So thorium is just an alternative nuclear fuel, but we're not looking at it. So thorium has high efficiency. 99% is burned. It's a natural breeder reactor. We've got about 500,000 years of thorium easily available. We've got 200 years of thorium sitting in waste dumps at present because nobody knows what to do with it. We used to use it for making those filaments on hurricane lamps and so on. They were made of thorium, some of those, because it's not radioactive, surprisingly. That's very interesting. So we've got lots of thorium hanging around. You can't make nuclear bombs from it. You don't need a separate reprocessing plant. There's no long half-life waste products. So the waste products are only 200 years, 300 years. So that's an advantage. And it's naturally stable. You can make a core that will not melt down. The problem being that the government is putting no money into thorium research. Oodles of money is going into unreliable renewables, but nothing is going into thorium, when quite possibly it could be our salvation, as it were. So in summary, we're coming to the end. You'll be glad to know. CO2 is the most essential gas in the atmosphere. Without CO2, all life on Earth will die. CO2 is not a very powerful greenhouse gas. I'll talk about that in a minute in the next lecture. Climate change is not as bad as advertised. We've already seen that with the hurricanes and the tornadoes. They're reducing. Most renewable energy needs stored backup, but nobody is looking at making stored backup. In fact, nobody's even discussing the fact that we need stored backup. Mandating electric vehicles and electric heating without generating capacity to underpin it is utterly ridiculous. However, alternative energy supplies are required because we will run out of fossil fuels, whether it's 200 years, 100 years, we don't know. At some point, especially in Britain, we're going to run out of fossil fuels. I think 60% of nuclear power is required. Why not? The French are running with 70% nuclear power, and they're doing fine. Their energy bills are half of ours. Yeah, we made a bad move when we started moving away from nuclear power, I think. Uranium is a limited resource, though. If everyone piles into uranium, like the whole world suddenly wants their energy from uranium, it suddenly becomes a limited resource. And that's a problem. So the alternative, possibly, because we don't know, is thorium power. Now, the Americans did make a thorium reactor back in the 1960s, and it worked. So it was proven that it will work. But obviously, we have not tried it on, that was a research reactor. We've not tried it on a commercial basis. And so the government is not serious about keeping the lights on, maintaining our wealth and prosperity. So that is the ender. And the main takeaway from this talk, I hope, is don't panic. Because the world is not going to end in 5 years, as an uneducated teenager tried to tell us. And it's not going to end in 12 years, as an uneducated member of Congress tried to tell us. So let's have a rational discussion about this, and let's create an energy policy that's based on logic and rationality. So anyway, I hope you found that interesting. That's my talk.
Going back to the chart at the start of your presentation with CO2 levels and temperature, you said historically high CO2 concentrations, atmospheric CO2 concentrations, resulted in a decrease in temperature?
Yes.
Is that correct? In the dinosaur era, you said atmospheric CO2 was about 2,000 parts per million.
2,500, yes.
Was the dinosaur era warmer than we're currently experiencing now?
Well, this is the problem. If you look at the CO2 versus temperature going back millions of years, obviously the dinosaur era is like 70 million years ago. There is no real correlation between temperature and CO2. No correlation at all. The correlation you saw there is only over 800,000 years, so that's less than 1 million years. There we see correlation, and the reason we get correlation between CO2 and temperature is because the oceans are soluble. So when we get cold oceans, they suck in the CO2. When we have warm oceans, like we have now, we're in an interglacial, the oceans will outgas CO2. So that's where a lot of our CO2 is coming from. It's not all of our output, it comes from the oceans. So does that explain?
Yeah, I think the way I was looking at it, it doesn't make sense from your graph earlier on, the highest CO2 concentrations.
Yeah, well, this has always been, we're going to discuss this in the next talk, but this has always been the problem with people trying to explain how the ice ages happen. Because if you look at the graph, high CO2 results in cooling, which is totally the opposite of what they're trying to use in their papers to explain the ice age cycle.
And you mentioned you reject the tree rings as a reliable source. What about the gas analysis within ice core samples?
That's
We've got
much
very
better.
accurate CO2 levels trapped within the ice.
Yes, so the question here was about tree rings, how good they are in comparison with the ice cores. The problem is with ice cores is they don't record the last 1,000 years because the ice does not seal itself for hundreds of years. They call it firn, which is the top layer of ice on Greenland and in Antarctica, and it doesn't seal itself for about 300-400 years. And so you cannot get a gas analysis for the last 1,000 years. It's very difficult to get a gas analysis. You can do it for millions of years, but not for the last 1,000 years. And so you have to rely on a different proxy. And so what they've been using recently is, well, tree rings, oceanic sediments with the different I forget what they're called. Anyway, the little animals that get embedded in the seabed, using those as temperature proxies instead, and sometimes with stalagmites and stalactites. So there are other methods of getting temperature, but tree rings, I think, is the worst of all of them. Missed you.
Hello. I'm just wondering, if you are right, what do you believe is the motive behind protecting
The alarmism.
Yeah, exactly. Particularly given the extent of vested interests tied up in fossil fuels and maintaining the status quo. The other question I have is, what about species migration? Because I think, and I'm not an expert, I'm just somebody who's trying to listen to different arguments. There seems to be a lot of scientific evidence about species migration due to climate change. What about bushfires?
Yeah.
And what about
them,
retreating
so
glaciers?
Yeah. Number of fires have been decreasing for 100 years. The problem is we've now got a 24-hour news cycle, and you can hear about a fire over in Kalgoorlie in Australia, which you would never have heard about before. But if you look at the USA forest fire chart for the last 100 years, they had 10 times as many fires back in the 1920s as we do now. So it went all the way down to the 1970s, roughly, something like that. The number of fires went down and have slightly been increasing again, mostly because of very poor forest management. Because of the Greens started saying it's all natural, you can't go around the forests and pull out all of the debris. So they were building up huge fuel loads in the forests, and then when you have a fire, you get a big fire. Back in the sort of 30s and 40s and 50s, they were doing a lot more forest management, and that reduces the fires. And the other problem is they're building houses in forests. You know, that town in America that burnt to the ground, that was built in the forest because people want to be in tune with nature or whatever. So they built the town inside the forest. Well, if you don't have a big fire break between you and the forest, you're asking for trouble. What was your first point? It was about, why are people doing this? That's open to debate. The debates I've had with left-wing Labour supporters is that they wanted a one-world government. And one of the ways you can get a one-world government is you have one-world problems, like climate, like COVID, all of these other things. And then you need a taxation system to go along with it that will fund that one-world government. And that was called the carbon tax. So that could have been one of the reasons why people wanted all of this climate alarmism. The other problem, of course, is that lots and lots of people want to jump on the bandwagon because it's virtue signaling. You are, you know, the good in the world because you're saving the planet. You care for the planet. Those horrible people over there, like Ralph Ellis, he doesn't care about the planet. I'm virtuous. And so you get a lot of bandwagon jumpers as well, who jump onto this bandwagon because it's nice. Who doesn't want to save the world? That's two reasons. You can probably think of many more reasons. I don't know. There's probably any other reasons?
They want us to freeze to death.
Yeah. Yes.
I could say you're sponsored by the oil industry.
Oh, they always do. But of course, where's my check? You know, show me the check. You know.
But the thing is, this sort of paranoia is not really. And if you give some good scientific data, that's a better argument.
Oh yes.
Than start.
And perhaps I should say that all of that data is pure, we're nearly finishing, yeah? All of that data is pure data from the recognized authorities in the climate field. The only difference is I'm giving you the data and the mainstream media are not giving you that data. That's the only difference.
So it's not paranoia, and that's not a way to do anything in the world.
Last two questions.
Yes, okay.
Just to take a different tack, I've read about the Rockefeller family hijacking oil back in the 20s, 30s. It's not a fossil fuel. It's actually a renewable energy that regenerates every 10 years. And they thought they'd take hold of this and they'd turn it into one of their money-making, control the population scams. What is this all about? Can you enlighten us on that? Because I'm not sure that this fossil fuel at all.
We're talking here about the idea that fossil fuels come out of the mantle of the earth and therefore are being renewed. I don't believe this is true because you do not find oil in the decant traps. If it was coming from volcanic activity, the decant traps would be full of oil, which it's not, of course. That's the big volcanic vast plate in India. You find oil in sedimentary rocks, which is where, you know, from the Jurassic era. And if you look at coal, you know, I used to be a coal miner, basically. If you go down into the coal mines, all of the coal seams will have fossils all the way through them. Coal is fossil fuel. You can see the fossils in the coal. So no, I don't think it comes from the mantle. The decant traps is the biggest volcanic shield in the whole of the world. It evolved during the dinosaur era. Now, you all know the meteor that hit in the Yucatan Peninsula that is supposed to have wiped out the dinosaurs. Well, at that very, very same time, on exactly the opposite side of the Earth, there erupted the biggest volcano there's ever been in sort of like recorded history. And it may have been a result of that impact, you know, with the shock waves running through the Earth. And suddenly we ended up with the Deccan Traps in India, which is an enormous great shield volcano, basically.
Last question.
Thank you for your talk. I have a couple of comments and a question. So I would agree with your requirements for storage if we're going to successfully navigate this transition. Just a couple of points. On your depiction of China, a fundamental point that you didn't share with us is that we have to look at emissions at a per capita level. So emissions in China are significantly lower than in the UK on a per capita basis. Making some statements about food production we should also remember that over the last 30 years, the way we produce food has significantly improved in our production methods and the way we use fertilizers. I'm not saying that that's great, but it's a fact. In noting that 1 degree of temperature rise in the Arctic is insignificant is also, I find, alarming, because a degree of temperature rise in the Arctic results in significant ice loss and therefore sea level rise.
Well,
it's not necessarily the number of tornadoes which is a problem, but their intensity and therefore the damage they do to civilization.
Yeah, I was using the intense ones.
Yeah, and I think when we're looking at carbon dioxide, we should also remember that we're only using carbon dioxide because it's freely available, as you quite rightly say, and it's easy to track. But it's just one of the greenhouse gases.
It is,
and methane is 60 times more potent.
Yeah, but there's very, very little methane in the atmosphere.
There's
The biggest of the greenhouse gases is water vapor, not CO2.
We use that
so
to track.
Yeah.
Yes, it's not necessarily that it's in itself is dangerous. We use
but there
it
is no
to track.
evidence that CO2 is causing warming.
Well,
It's all correlation. There is no evidence. The only evidence
having done some regression analysis, I can tell you that I disagree with that.
The only evidence we have that CO2 is causing warming.
My question
is, you got another one?
I have, no, those were comments. My question is, climate change is affecting mainly those who live in countries where fossil fuels are not burnt, and the damage is being done on a global level to their lives. We in this country have the ability to adapt and mitigate. So
Only
what
if
is
you
your
think
take?
CO2
What is your take on how the intensity of the climate system is affecting people in the Sahel and in small island states which are losing land mass and therefore their ability to thrive?
Yeah, can I talk? The Sahel is getting greener. It's getting better for them than it was before. Why is the Sahel getting the Sahel is the bottom of the Sahara Desert, basically. The Sahel is greening because of extra CO2. CO2 is plant food, but more importantly than that, it is CO2 is plant food for arid regions because the stomata are allowed to close up. So it reduces transpiration. So the Sahel is growing more food than it has before. So it's actually of benefit to people in the Sahel. Now, going back to whether CO2 is actually doing anything, we'll have a look at this on my next talk. But the only evidence that CO2, i.e. greenhouse gases, are doing anything to temperature is not the surface record. That's totally irrelevant. What you have to look at is the tropospheric tropical tropospheric temperatures. So at about 35,000 foot around the tropics. That is the true indicator of greenhouse warming, because that is where the greenhouse warming starts. It starts in the troposphere, and it is the troposphere that warms the ground, not the other way around. So if you want to know what's happening with greenhouse gases, you need to measure the temperatures in the troposphere. And this has been done, not for very long, because it's only on the satellite record and with a few radiosondes that they send up. The warming that they've determined in the troposphere is only 1/4 of what the IPCC is giving for greenhouse warming. So that's the problem. They're giving a figure for greenhouse warming of about 4 degrees 4 degrees per century, I think it is, something of that nature, for a doubling of CO2. If you measure the temperature in the troposphere, which is the true indicator of greenhouse warming, it's only 1.1 degrees. And now you can have a look at that. That's by Dr. John Christie. This is not my work. Dr. John Christie, who works at the University of Alabama, Huntsville, and he runs the NASA satellite data from the satellite. And it's freely available online. What does he call it? The paper is called the tropical, I'll have to look it up, the tropical troposphere or something. Anyway, it's a paper he wrote for the British Parliament just about 5 years ago. And it's a very easy read paper for anyone that wants to look it up. So I'd recommend people do that. I'll get the name of it later so I can give it to you.
Okay,